Assalamualaikum and hi guys, this is 7.2 part 2. 7.2 is on acid-base titration. Here are the learning outcomes. At the end of this lesson, students should be able to A. Sketch and interpret the variation pH against titration volume for titration between strong acid, strong base, strong acid, weak base, and also weak acid and strong base. So we are going to do some sketching here. Let's get excited. So there are three titration types, which is based on acid, strong acid and strong base, strong acid and weak base, weak acid and strong base. So we are going to look into each titration types one by one in this lecture. So we're going to start for sketching the titration curve for a strong acid and a strong base. So for example, the question given, sketch the titration curve for the titration between 40 ml of 0.1 molar HCl with 0.1 molar NaOH. So we can see here that this is a known volume 40 ml. That indicate that this HCl is going to be the analyte. Meanwhile, this unknown volume is going to be the hydrant. Right, so first, before doing anything else, please write the neutralization equation first. So HCl equals plus NaOH equals produces NaCl salt and also H2O liquid. Next, right? This is an example of the drawing. Right? If you cannot visualize, it's better for you to draw. So now, as I said earlier, NaOH is going to be the titrant. Titrant is the solution inside the red. Meanwhile, our analyte is the solution inside the conical flask. So here, you can sketch the titration curve. So titration curve shows the variation between the pH and also the volume of titrant added. So as in this case, our titrant is NaOH, therefore say here volume of NaOH added in ml. So my tips is, when you are going to sketch a titration curve, first you need to identify the titrant and analyte, and then you draw the y-axis and also the x-axis. The y-axis represent the pH. Meanwhile, the x-axis represents the volume of titrant added. In this case, our titrant is NaOH. Therefore, you write volume of NaOH added in ml. Next, what you can do is, since this titration is between a strong acid and strong base, you need to draw the vertical steep portion, which is here. From here, for the titration of strong acid and strong base, the pH range of equilibrium point is from 4 to 11. So draw the steep vertical portion here, and then you can label the equilibrium point, which is the pH of the equilibrium point, as we all know, for the titration of strong acid and strong base equal to 7. Right, and then we start to draw the curve. Right, why do we start from bottom? Because initially, before we begin the titration, you can see that inside the conical flask there is just HCl. HCl is a strong acid which dissociates completely in water. Therefore, the pH value is low, right? And then, as we start to add our titrant in drop by drop, or we can see gradually, right? We can see that there is an increase in pH value. Why? Because H plus ions in HCl in the conical flask is being neutralized by the added base, which is the added NaOH. This leads to a decrease in concentration of H plus. When the concentration of H plus decreases, pH increases. Therefore, we can see that the pH start to increase gradually. But when it almost reach towards the equivalent point, right, there is a steep vertical portion. That means the pH increase drastically, right, ranging from 4 to 11. So here at the equivalent point, we say that acid and base has mixed stoichiometrically. That means both neutralize each other. After the equivalent point, the pH continued to rise because now we can see that we continue adding NaOH. So that means NaOH is in excess. So in order to correspond for the NaOH added, NaOH is a strong base, therefore the pH of the solution continue to rise, okay, up to ranging between 13 to 13. So how do we know, when plotting this, when sketching this titration curve, how do we know this tip bar is at 40, right? Because we have to do some calculation here. So we use this as this equation, MAVA over MBVB equal to A over B. A over B is the stoichiometric ratio. Therefore, you must write down the equation correctly first. So we can see here, the molarity of acid is given 0.1 molar, volume is 40, and the molarity of the base is given 0.1. So stoichiometric ratio is 1 to 1. So 1 over 1, therefore you can determine the volume of base you need to add in order to reach the equivalent. So therefore, we mark here the equivalent point lies on when you add 40 ml of NaOH. So let's see what species is present in the conical flask throughout the titration process. So we can see here, at the beginning of the reaction, there are no NaOH. We just have HCl inside the conical flask. Next, before reaching the end point, there are unneutralized HCl and also the product of the titration, which is the salt and also the water. Next, when there is 40 ml of NaOH added, the reaction has reached its equivalent point. Therefore, there is no more acid or base left. What's left inside the conical flask is just NaCl and water, right? And then beyond the equivalent point, there is an excess of NaOH, and also the product of the titration, which is the salt and more clear, right? Are you okay? Simple. It is very easy to sketch the titration curve. Next, let's say if we have, right, the example just now, if HCl, our acid, become the analyte. How about when the base become the analyte and the acid become the titrate? How does the titration curve look like? Simple, right? You just have to flip the titration curve, right? As I said earlier, first this sketch the y-axis and also the x-axis. So for example, like this case, right? Like this case, that means that when the titration curve, this titration curve start from a very low pH, that means the solution inside the conical flask is acid, and then that means the titrant is base. Therefore, we start with a very low pH, and then for the titration between strong acid and strong base, please make sure you label the steep vertical point here, right? The steep vertical point is constant, which is 4 to 11, and then this is the equivalent, right? When this is the case, the titration, the pH will start from very low value and then we start to rise up till beyond the equivalent point. Meanwhile, if there is another case where inside the conical flask is the base, strong base, meanwhile the titrant is the acid. So we are going to start the titration curve with a very high pH, indicating that this is a strong base initially, and then when we keep adding the acid, it will neutralize the base and the pH will go down. Okay, will go down after the titration, after the equivalent point. Got me? So you need to carefully read the equation, whether the acid or the base has become the titrant. Okay, clear? So we move on to the next step of titration. So now you need to sketch the titration curve for a strong acid and a weak base. For example, given 25 ml of 0.1 molar ammonia. Ammonia is a weak base. HCl is a strong acid. So now given the volume. When given the volume, that's mean this is the solution inside the conical flask. Therefore, initially is going to be the analyte. Right. So if you cannot visualize, you may draw first, right, in order to avoid any mistake. So as I said earlier, analyte is going to be the ammonia. Meanwhile, HCl is going to be the titrant. So write down the neutralization equation first. 1 mole of HCl react with 1 mole of ammonia, forming NH4Cl aqueous. So this is the salt form. So how do you sketch the titration curve first, right? Draw the y-axis and also the x-axis. The y-axis represent the pH, meanwhile the x-axis represent the volume of titrant added. In this case is HCl. Next, as the solution inside the conical flask is the weak base, so that means our titration curve is going to start from pH more than 7. It is ranging. The pH of the weak base is about 11. Next, you have to plot the steep vertical portion. For the titration between a strong acid and a weak base, the pH range of equivalent point is from 4 to 7. Therefore, you draw a straight line here, a steep vertical portion here, and then the equivalent point or the pH of the solution at equivalent point must be less than 7. So, now for this question, right, we can calculate the volume of the acid that we should add in order to get the equivalent. So by using the same formula, MAVA over MBVB equal to A over B, substitute the value given, and then the volume of the base is about 25. Right. Next, the same case, let's say if your titrant, right, if your titrant is the base, that means initially the solution inside the conical flask is your acid, as your strong acid, so the titration curve is going to start from below, right, from a very low pH, and then the pH keep increasing up till the pH of the weak base. Another example, let's say if your titrant is acid, that means the solution inside the conical flask initially is the weak base. Therefore, your titration curve will start from pH more than 7, indicating the weak base, and then the pH will go down, right, as the titration process proceeds. Okay, now we move on to the last type of neutralization, which is the between the weak acid and a strong base. So for example, the question asks you to sketch the titration curve between 25 ml of 0.1 molar ethanoic acid. Ethanoic acid is a weak acid with 0.1 molar sodium hydroxide, which is a strong base. So first thing first, please write down the neutralization equation first. And then from the information given, we can retrieve that this is going to be the analyte. Therefore, it's going to be inside the conical flask. Next, we can sketch the titration curve, which is pH again, the volume of titrant added. So, our titrant is NaOH. And then, what you can do is label the steep vertical portion, right? For the titration between weak acid and a strong base, the pH range of equilibrium point is between 7 to 11. 7 to 11. And the pH of the equilibrium point will be more than 7. So now, as you can see, because at the beginning of the titration, what's inside the we only have ethanoic acid inside the conical flask. Therefore, our pH, our titration curve is going to start from a low pH, and the pH will keep increase gradually until the titration process ended. Right? So in order to know where does the equivalent point occur for this titration, so we can do the calculation by using the formula. So from the calculation, we can see that in order to neutralize completely 25 ml of 0.1 molar ethanoic acid, we need 25 ml of sodium hydroxide. Right? Therefore, the titration curve look like this. Are you clear? Okay, thank you for watching. Bye.